Welcome back to my channel Bal Vigyan Bharti with your mentor Abhilash Sarkar. As we have started problem solving on demand, on time, speed and distance, we have moved three problems. Means we have shown you solving three different problems. Now we'll show you more. So moving on to the problem number 4. This problem says Amit and Aman have to travel. Amit and Aman have to travel from Delhi to Jaipur in their respective cars. Delhi to Jaipur in their respective cars. Amit is driving at 60 km per hour. Amit is driving at 60 km per hour while Aman is driving at 90 km per hour. While Aman is driving at 90 km per hour. Find the time taken by Aman to reach. Find the time taken by Aman to reach Jaipur if Amit takes 9 hours. Okay, so here two friends or two person who is traveling from Delhi to Jaipur. So you need not to know the exact distance between the Delhi and Jaipur. Don't be bothered about the distance. There are some distance that can be represented as a unknown value of x. Let's say now Amit, the first is Amit, the second is Aman. Both are traveling the same distance with their own cars. One is Amit is moving with 60 kmph while Aman is moving with 90 kmph. So definitely they will take some time to reach that. Let's say time is t1 for him, t2 for him. So now Amit takes 9 hours. So Amit, this t1 is already said to be 9 hours. The one factor is known. Distance are same. So we can assume the distance traveled by Amit is distance traveled by Aman. This is a perfect equation. Both the distance are same. So for Amit, how will you calculate the distance? Distance is the speed for Amit into time for Amit. Distance is equal to because this is uniform speed they are moving. So the speed of Amit, time of Amit equal to speed of Aman into time of Aman. So this is the simplest equation that can be used here. I will not go with the T1, T2, rather I will write all this with their name. This is time of Amit, time of Aman. Okay. The speed of Amit is what? 60. So now put the value there. 60 is the speed. I am not changing here also the units. Why? This is kilometer per hour. This is kilometer per hour. This is hour. So there is no need because all are in same time unit are same. So whatever I will get, if it is length, I will get in kilometer. If I get in time something result, I will get it in hours. So there is no need of changing any unit. Every time I will say why the changing of unit is needed, where the changing of unit is not needed. Just follow me. So S of Amit is 60. Time of Amit is known because this is already declared. So this part is known, equal to what? S means speed of Aman. Speed of Aman is what? Aman is driving at 90 kilometers. So this is 90. And time of Aman is not known. You have to find this Aman time. This is the requirement. So this is exactly the simplest solution that anybody can think of. 10. So the time is in hours because I have not changed any unit. So this is your answer. So time. So your answer has to be concluded, and that conclusion will be the Aman is taking 6 hours time to reach Jaipur from Delhi. Okay. Okay, moving to problem number 5. Okay, a man, not a man, this is a man. A man travels from his home to office at 4 kilometer per hour, at 4 kilometer per hour, and reaches his office (20 minutes) late. Okay. If the speed had been, speed had been 6 kilometer per hour, he would have reaches would have reached 10 minutes early. 10 minutes early. Find the distance from his home to office. Now, how will I get this solved? A man traveled from his home, so there is a 2 point. One is starting point, that is home. One is ending point, that is destination, is office. Home to office at 4 kilometer per hour. So his speed for the first kind of journey is 4 kilometer per hour, reaches his office 20 minutes late, reaches his office 20 minutes, so that must be with respect to some other time. So his office and reaches, so that means if he follows this speed, he is reaching at 20 minutes late to the usual time of reach. So I can say this is the usual time of reach is TU, and he is 20 minutes late to the usual time, because there is no other option for me to correlate this value. So that means if he follow this speed, he could have go 20 minutes early if he had followed some other speed, but following this speed he's become late 20 minutes. So the usual time with some other speed has to be TU, but this case it is to be TU plus 20. Okay, so this is the first part. I can put it into form of this. If the speed had been 6 kilometer per hour, so this is S1. The second condition, the speed is 6 kilometer per hour. Okay, fine. He would have reached 10 minutes early. So now speed is being increased. So definitely he will reach office then the lesser time the earlier. But how much lesser? It is saying 10 minutes early. That means 10 minutes early to what? Here is the twist. You have to understand. If speed had been 6 kilometer per hour, he would have reached 10 meter early. That means early to what time? You should not confused with this time, because your reference point is the usual time with some speed that is not mentioned. With that reference time, this is taken as late or early. So this case also we can say that time has to be usual time minus, because he is reaching 10 minutes early, TU minus 10. Understood? So my point of reference has to be the usual time that may reach with the speed a speculated, or a time, or a speed that could have get him to office at usual time. But that is not known, that is not even needed, because find the distance from the home. So only requirement is distance. Okay, so true cases are that speed is this, time is usual time plus 20. If speed is this, the usual time minus 20. Now from this, only unknown is usual, means I will get usual time within which he can reach office. So how will you do that? Because in this case distance also same. So both the case distance, because speed into time if I do, so that means the first case S1 into, let's say this is mentioned as T1, this is mentioned as T2. So my simple equation will be S1 into T1 is equal to S2 into T2, because distance is same. He is moving with the uniform distance. Each case means when he is traveling, he is not changing his speed. So for that case, the distance, if I want to calculate, that will be the speed into time. And second case also with the same speed is moving, so speed into time. So from there I can say that 4 into instead of TU I am writing only T, just to give it a good look. Okay, I am not writing T2, instead of that I am TU, I am writing T only. So this is 6, because S2 is 6 and time is T minus 10. So this is a one variable one equation. This is very much able to solve, because the rule of the equation is that the number of variable, you need at least that much of that number of equations. If the unknown is 2, you need to have 2 equations. Otherwise you cannot able to solve, unless and until some trial and error value you can take. So that is one method of solving two variables with a one equation, but that is a rare one where things are being described such a way. But overall, in other cases, when there is two variable, two unknowns, you need at least two equations. If it is one variable, it is one equation is enough. So in this case, only one variable is there, t. So it is very much able to solve. So let me solve it because t is needed here. So you can reduce to is the calculation. So this will be 2t plus 40 is equal to 3t minus 30. So t, if I take this side, this will be t, and 30 will come this side, this will be 70. So time is 70. So 70 is what? 70 minute. Oh, now one thing is that now here also I am not changed the unit, because both this is the we are equalizing two sides. Now if I see this unit and this units are same in the same unit, means this is 6, this is 4, then unit of measurement are same, and this is being established in both side of the equation, so there is no need of changing. Even though the time is in minute, this is in kilometer per hour, even I am not changing, I am not bothered to change, because this will nullify their units on the other both sides. So unnecessarily go to reduce or means increase my pen by changing, unless and until these two units are different, then only I will try to change. This case also I am not changing because this will nullify. Now remember that then that case, if t values are given, I am putting the values of t with the unit, this will nullify each other. Now I am calculating t only, so that t will be in the same unit, the other time unit is given in that unit. So here your answer would be t will be in minute, not in hour. Don't be confused, because otherwise you will make mistake. The time individually is given in minute unit. So whatever time you will get as an individual case, so that time will be followed minute unit. Okay. So this much time is taken to travel the total distance, that usual timing. Now if it is usual timing, now how will you means what is the distance, how will you calculate? So distance, any of this you can calculate as a you can use for calculating the distance, because what distance for first case, if it is taking 20 minutes more, the distance is equal to what? S1 into T1. So S1 is equal to what? 4 kilometer per hour into, now here remember, when you are only calculating individual case, that means this unit with some other unit, that means 4 kilometer per hour and time unit is in minute I am getting, there you need to change the unit, because hour cannot merge with minute. That is in individual case, only time is coming. So both the sides, that is equalizing each other. The S1 unit, S2 units being cancelled, only time units is remaining, as this is unknown. So this time is taken without changing the units. Now here I am doing something kilometer per hour with time minute, that will not merge with each other, rather you have to change. So how will you change that? Now S1 is value is, I am using the first case where distance is S1 into T1, 4 into T1, that means usual time, that means 70 plus 20. That was the equation, and here unit is kilometer per hour into time unit is minute. Now if you write units side by side, you will automatically able to automatically able to solve this, or you will be able to know where you need the change. You write the equation side by side. Don't ever means scared to write the units side by side, because that will give you always alarm to wherever it is need changes. Okay. So 4 into 90, that means 360. Calculation part is okay. Now I will change kilometer. The kilometer, so the numerical part will be calculated with the numerical. The kilometer to meter, if I want to change, that will be or let's say I'm not changing kilometers. I'm keeping it kilometer because I need in distance in kilometer. So let it be kilometer, and the time unit is hour. 2 minute. It will be 60 there. So this case, this will turn into minute. Hour will be 60 minute into minute here. So minute will be cancelled out. Only remaining is kilometer. So this 60 will calculated here numerically. So this will give you 6 kilometer. Now understand how I am changing. I am calculating units with a numerical. Numerical already calculated. Now while I am changing the units, this hour will change into 60 minute, 60 into minute. This minute will be cancelled out. Unless and until I change it to minute, I cannot cancel out hour into minute because those are not in the same unit. Units can be cancelled out if they are in same designation. So to put it in same designation, hours can be written as 60 minute. So minute cancelled out. 60 will be calculated with the numeric part, and kilometers will remain with the units. Okay. So 6 kilometers. So this is 6 kilometer. Okay. So so now. Fine. So moving to the next problem. This can be also calculated using S2 T2. Any of these two you can use. The distance will give you the same result because distance will S1 T1 for the first case. Distance will be second because S2 T2. So any of this equation you can use to solve the case, but your distance will be 6 kilometer. Okay. Okay. No. So the problem number 6. Okay. Problem number 6 is Ram can row a boat in still water at 10 kmph kilometer per hour. He decides to go boating in a river. To row upstream, he takes 2 hours, and to row downstream he takes 1.5 hours. Find the speed of the river. Find the speed of the river. Okay, fine. So as you can see, the Ram can row a boat in still water. Okay, so 10 kilometers. That means whatever force he can put on the on his you can say on the what does it call in that sheep is being troubled by the manual manual you can say what does it call that some haul is being used now, so that manual haul with that the seaman boatman put force on the water, and by that force a reactive force is thrusting him towards the opposite side of the force he is giving on the water. So that is, you can say, as a haul or something else it's called. I call it as a plank. Let's say the boatman, the ram is putting force with the plank on the water, in a still water where there is no current of the river. He can create a speed of 10 kilometer per hour. So that means this is the ram's boat speed. I can say that this is the pure speed of the boat in still water. B you can assume this will not be being influenced by the river current. So, and on the side, if river current or the river speed, basically you can say speed be taken as r. Now when a boat is traveling with the river current, means if the river current is this way and the boat also moving this way, so they are being added up. This is the concept of a linear you can say kinematics, where if two scalar or vector moving in the same line, then if those scalars are of similar criteria or similar you can say the properties, they can be added, as speed can be added, and if it is distance traversed, that can also be added. So in this case, the speed of the boat is b, speed of the current of the river is r, and they are in the same direction, then they can be added. So while, and one more thing, if student cannot understand between the term upstream and downstream, there are two method of understanding. Upstream is where you are going something up. So when you are moving up, that means you are doing more, wasting more energy. That means there are resistance. So when you are moving up, that will definitely take time. So conceptually or common sense says, if you move up, it will take time. So upstream is you are going against the river current, and downstream is if you are going down, so definitely it will help. That also be true when you are moving up, you are lifting your own body, so that will be more energetic case. When you are moving down, your body itself is giving you force. So upstream is somewhere you are getting resistance, so that's why the time is taken more. That also is a clue which one is to be, where you have to add a river current, where you have to deduct river current. When time is more, definitely you are going against the reverse. So this is boat speed already known, 10 kilometer per hour kmph. Only this has to be known, so I can assume this also to be in kmph. If not, other units are also in hours, so need not to change the unit. So your time taken for first case is 2 hours. So the distance b I am taking as d, the total distance, where I am comparing something between those timing. So my distance has to be same. I cannot consider different distance and I can compare. I have to take the same distance they are traveling and different time. So distance same. For first case, your speed would be, when time is more, speed must be, the denominator must be less. So from that concept also, the boat speed minus river speed, that will give you the time, that is equal to 2. And for second case, d upon b plus r will be the lesser time, because that denominator is higher. So this is 3/2. 1.5 means this, if we convert in fraction, that will be 3/2. This is improper fraction, you can say. So this 3/2. So now from this 2, if you divide this upon this, so this ultimately will give you what? B plus R by B minus R. If we divide this by this upon this, so this will turn on the up on the top, this upon this, that means this by this on the 2, 4 by 3 isn't it? I am dividing this by this, so d will be cancelled out, b plus 4 will go up, b minus 3 will be there, 2 upon 3 by 2, 4 by 3 is fine. Now b is already known 10, I will put it like that, so 10 minus r, so that it will be 30 plus 3r, 40 minus 4r, so ultimately 7r is equal to 10, so that means r is equal to 10 by 7. So r is the speed of the river, so that is equal to kilometer per hour. So you need to change the unit, so it straight by you can say this is your answer. So I will end up here. Next video I will move to number 7 and I will solve so many problems so that all concept can be cleared. Okay, I will try to bring more variety of problem so that everything can be cleared easily. So thank you for now. Good night.